In the 3 videos that came before this one, we built this unit circle. In this video, we're going to go over why we built the unit circle, how we're going to use it, and we're going to use it to find trig values very easily without having to use a calculator. Here's what I mean. So we have this right triangle. That means we can use right triangle trig from geometry. SOH, if you learn that, SOH is sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse, get it? CAH. And tangent is opposite over adjacent. If you are at this 30-degree angle, your opposite side is this one. Your hypotenuse is the radius of your unit circle, and your adjacent side is this guy. The adjacent side is not a radius. It doesn't go all the way to the end. We know what all these side lengths are. The hypotenuse is 1 because it's a unit circle. But the thing is since you know the x, y values for this point, you know these other sides as well. The adjacent side is the length on the x-axis, so that is the square root of 3 over 2. The opposite side is how far you went up, which is the 1/2. That's your y value. So the cosine of 30 degrees is going to be adjacent over hypotenuse. Well, the adjacent side is square root of 3 over 2, and the hypotenuse is 1. So we end up with square root of 3 over 2. I did cosine first on purpose because the cosine value ends up being your x value of that point. The sine of 30 degrees is opposite over hypotenuse. 1/2 divided by 1, which is 1/2. The sine value ends up being the y value. And all this works because of the magical unit circle. It has the hypotenuse equal to 1. That's why this works so great. Cosine of 30 degrees ended up being our x, and the sine of 30 degrees ended up being our y. Okay, so that's 30 degrees. But the thing is that's true for all the angles on a unit circle. The x value will be the cosine, and the y value will be the sine of that angle, no matter where it is. Quadrant 1, quadrant 2, anywhere. So let's look at just quadrant 1 instead of looking at the whole unit circle, just so you can get an idea here. The x value is the cosine, the y value is the sine. So if we look at 90 degrees, the cosine of 90 degrees is 0. And the sine of 90 degrees is 1. 60 degrees, the cosine is 1/2, and the sine of 60 degrees is square root of 3 over 2. You really can't screw up the 45-degree angle. It's a beautiful thing. Cosine of 45 degrees is square root of 2 over 2, and so is the sine of 45 degrees. 30 degrees is the one we were just learning with. The cosine is square root of 3 over 2, and the sine is 1/2. And they're all printed right here on your unit circle. Let's look at 0. The cosine of 0 is 1, and the sine of 0 is 0. We know that cosine is x and sine is y, but the thing is there are actually 6 trig functions, and here's only 2 of them. If you want to find tangent, you've got to use the tangent identity. Tangent of theta equals sine theta over cosine theta, but we know that sine and cosine are y and x. So tangent is y divided by x on the unit circle. Then you have secant. Secant is the reciprocal function for cosine, 1 over cosine. In this case, that would be 1 over x, would be the secant of theta. Cosecant is the reciprocal function of sine, 1 over sine, but since sine is y, we're going to write it like that. And the last one is cotangent, which is the reciprocal function of tangent. Well, tangent is y over x, so cotangent has to be x over y. Now, right here, take a screenshot so you have it. Let's play with them. Use the unit circle to calculate the 6 trig functions for the given angle. Let's bring in my little cheat sheet. So I have all my little formulas. Now look at your unit circle and get the point, which would be in quadrant 2. So it's negative root 3 over 2 and 1/2. So the cosine is going to be the negative root 3 over 2. The sine is going to be 1/2. Tangent. Well, the tangent is y divided by x. That's, since these are a little complicated, that's going to require some scratch paper. there's my point. I just copied it over here so it'd be handy. So the tangent is y over x. My y is 1/2. So that's on top, and my x is negative root 3 over 2. Now, when you are dividing fractions, you have to rewrite it as a multiplication problem, and you flip the second fraction over. So we get 1 over negative root 3. We need to rationalize that. I'm going to take the top and the bottom times root 3. That's to clear the radical out of the denominator. Now, this whole answer is going to be negative because the denominator is negative. So I'll just put that in the front. 1 times root 3 is root 3. Root 3 times root 3 is just 3. This is the tangent. So I need to copy that right here. Now secant of theta. Well, secant is 1 over x, which would be 1 over that lovely radical, negative root 3 over 2, which just means you're going to flip it over, and then you got to rationalize. So we end up with 2 root 3 over 3, but the whole thing is negative because the denominator was negative. Back to the answer sheet and just copy that in. Cosecant is easy because cosecant is sine flipped over. So you just flip 1/2 over, you get a 2. Don't have to do any work for that one. And cotangent, well, cotangent is x over y. So we're going to do the same thing. Now, yeah, you could have flipped your tangent over, but you would still end up with a bit of a mess. To clean up, there it is, negative root 3 over 1. Okay, let's look at a radian angle. I'm going to go for pi this time. And even though the point is a lot simpler, things start to get a little bit weird when there's a 0 in there. The cosine is negative 1, the sine is 0. Tangent is going to be y divided by x, so that's 0 divided by negative 1, that's 0. Secant, well, secant is 1 over x, and if x is negative 1, we have 1 over negative 1. That's negative 1 when you simplify it. Cosecant, be careful. You're going to be tempted to just say, well, the reciprocal of 0 is 0, but using the formula, it's 1 over 0. And that puts 0 in the denominator. And we all know what horrors happen when you try to divide by 0. So this guy is undefined. Cotangent is x divided by y. That would be negative 1 over 0. And again, undefined. Now, so if you're just jumping into this series here and you're wondering where that unit circle stuff came from in the first place, click into this video and start at the very beginning, and I promise you it'll make sense when you see how we build the thing from the ground up.